No, it's fine.
Hello, okay. Alrighty. Yulunga, welcome. It's a real pleasure to be here in Darawal country. So one does not simply traverse the stack. There's all kinds of frictions that you encounter. So I've been looking into ways you might unify it. So let's say you start with Billy, right? Billy loves video games. In fact, she loves them so much that she becomes an expert at MIT Scratch. She learns it inside out, which is great. But what happens is, as she grows up, well, she realizes actually there's a lot more to software development than computer science. You know, you've got to learn C#, you've got to learn game engines. There's this whole world that is kind of separate from learning to code or these no-code tools. And what happens as she's developing that game engine, she's got an idea for a feature, but it's not in the engine yet. Well, now she's got into the world of C++, and she's got to do all this wizardry. It's like another world again. So there's a lot of time spent here just going between ecosystems. And now the game's successful, and she needs to build a website for it. Same thing happens again. So you kind of got these these separations of ecosystems. And I think that this is a big problem in software development. It's something that I've been looking to approach. And okay, so I guess we get something here. We've got technological anchoring bias, something I've learned today. So you get people kind of wanting to stay in these quadrants because there is a lot of friction from moving across them, and we see the problems as being the problems themselves rather than looking for turtles, right? We kind of want something underneath that's going to underpin the entire stack, and of course they're going to have their own domain-specific stuff, but we want something to underpin it. But what do you need for that? Well, for starters, it has to be really, really fast because we do have these game engine and embedded environments and compilers. They need to be quick. So performance is key to this kind of stack. Another thing that's common across all of these domains is structure, right? Whether you're talking about DOM trees or resource dependency trees in the cloud, everything's got structure, so we need elegant ways to define these structures and work with them at runtime. Another thing that we need is composability, right? Because some of these structures have shared code, some of them have completely different ideas, so you kind of want to be able to share as much as possible, but add and remove as you need to. Another thing that you're going to need to be able to do is serialize the whole thing. No-code tools and a lot of developer tools like game engine editors, or whatever the equivalent for that for web development or something would be, are built on serialization. So you need serialization at a really fundamental level to make this sort of stuff work. And finally, decoupled behavior. So an example of this would be like a DOM tree would be the same state, but completely different behavior at build time than runtime. So you want the behavior to be separated from the state. All right, so this is ECS, Entity Component System, popularized by the games. You could think of it like a paradigm. I like to think of it kind of like a meta paradigm. It's just data-oriented approach to arranging code. And you could build all kinds of things like your signals or whatever on top of it. So how might an ECS stack look like? I think we've got to start with Rust, just because it's got the cross-section of these ecosystems. You're sort of hitting the ground running if you wanted to build on top of it. Next, you'd want your ECS engine. So this is Bevy. The interesting part about Bevy is it separates the game engine stuff, like rendering and input, from the actual ECS layer. So you can run no STD, tiny little ESP32 microcontrollers, no problem. It's also like the best, like friendliest community you'll ever be a part of. And this is what I'm building. So this is just the meta framework that sits on top of Bevy. Just like fills in all the gaps that are out of scope for a game engine, things like DOM templating, routing, build pipelines, that sort of stuff. And eventually, I hope to get to this idea of beat mash. And that's where you take other people's, apps. This is a sort of malleable software in local first, that sort of idea. You sort of take them and remix them, and you've got this no-code tooling on top of it all. And so there you go. So that now Billy's able to sort of start at the top and move down and across the stack as she likes. It's all ECS. Of course, there is that domain-specific stuff, but you're dealing with the same primitives at the core. And so that's the idea of beat. And yeah, so there's a progress so far. We've got like a web framework. We've got like some reinforcement learning experiments, and this is the idea of a decentralized scene registry. It's all super experimental, but a lot of fun because you've got this sort of ability to cross the stack without too much effort. And so please, if you're interested, you can check out beatstack.dev. That site's 100% ECS, so you can see it a little bit in production, but it's all very much under construction, and I'm really looking for people to build it with. So if you're interested, come and say hi, either today or online. Thank you.